the record button here, we're going to talk about the global context. In this case, I'm thinking of context as or at least what my dictionary says, context is the circumstances surrounding an act or an event. So we're going to look at the circumstances that surround our work as construction professionals. Our first week's lecture, we talked about some of the characteristics of sustainable architecture. Sustainable architecture is design, construction, operation of the building that does so in a way that works to minimize the human use of resources. So that's what we're going to be talking about. We'll be talking about the why. Why do we have to minimize the human use of resources? That's essentially what we're working on tonight. Let me run a little video here. Hold on.
Here. Happy Earth Overshoot Day. Well, there's nothing happy about it, really. This year, Earth Overshoot Day falls on August the 1st, the earliest day ever. Never heard of Earth Overshoot Day or the ecological footprint? Our ecological footprint is how much we demand from nature. Currently, humanity is using the equivalent of
back here.
Every year, Global Footprint Network calculates Earth Overshoot Day. It marks the date when humanity's demand on nature exceeds what Earth can regenerate in that year. In 2018, Earth Overshoot Day falls on August the 1st. You can think about this as a bank account. For the first 7 months and 1 day in 2018, we lived on our regular salary.
Am I the only one getting feedback?
We started into our savings and racking up credit card debt. Seems like there's something wrong with that math. The ecological footprint.
Did somebody have a question? Sorry.
I'm getting a lot of feedback on my end. I can't really understand the audio.
Okay. Is anyone else having that problem?
Yeah, I think you got to turn off your microphone on your Blackboard when you're sharing, because we're hearing it twice.
Okay. Let me see if I can fix that here. I didn't have the problem last time. Let me shut my mic off here. Hold on. If I can figure out how to do that.
Hi, Alex here. Happy Earth Overshoot Day. Well, there's nothing happy about it, really. This year, Earth Overshoot Day falls on August the 1st, the earliest day ever. Never heard of Earth Overshoot Day or the ecological footprint? Our ecological footprint is how much we demand from nature. Currently, humanity is using the equivalent of 1.7 planets. Every year, Global Footprint Network calculates Earth Overshoot Day. It marks the date when humanity's demand on nature exceeds what Earth can regenerate in that year. In 2018, Earth Overshoot Day falls on August the 1st. You can think about this as a bank account. For the first 7 months and 1 day in 2018, we lived on our regular salary. After that, we start chipping into our savings and racking up credit card debt. Seems like there's something wrong with that math. The ecological footprint measures how much land and water area we need to produce the resources we use, things like food, land for settlements, timber, seafood, and to absorb the waste and carbon dioxide we generate. Our biocapacity is the amount of biologically productive areas, such as forests, fishing grounds, crop and grazing areas, that are available to provide the resources we use and to absorb our waste. We can compare footprint and biocapacity to see if we are well balanced or not. Why do we care about humanity's ecological footprint? The costs of ecological overspending are evident every day in the form of deforestation, drought, biodiversity loss, and the buildup of carbon dioxide in the atmosphere. Ecological overspending can also put nations at more economic risk. Without sufficient resources, it is hard to operate an economy, or we have to import more, which has costs as well. Carbon emissions from fossil fuel use are a big part of today's footprint. Today, humanity's carbon footprint makes up 60% of the world's total ecological footprint. Individuals can measure their own ecological footprint with Global Footprint Network's new calculator. Mine is 3.5 global hectares. In fact, you can even calculate the date of your own overshoot day, the day when the world would go into ecological overshoot if everyone on the planet lived like you. If your overshoot day falls before August the 1st, that means your ecological footprint is larger than the world average. You can learn more about sustainability solutions by joining the Earth Overshoot Day #MoveTheDate campaign. Make steps to take actions to move back the date of Earth Overshoot Day and share them and the calculator with your friends and family. If we can move the date of Overshoot Day 5 days per year, we will be living sustainably on our one planet Earth by 2050. Help move the date, calculate your own ecological footprint and overshoot day today. Visit www.overshootday.org. This video was created
Okay, well, hopefully that's working better now. Let me go back to my slides.
Video was good.
Well, thanks for right. So, sorry, this is I've been using this slide deck for a number of years, and I try to keep things up to date here, but you know, the facts haven't changed that much in a couple of years. Essentially, they're looking at the balance between how much land, our ecological footprint, and the capability of the Earth to support the resources that we need. And the point that the gentleman in the film was making was that we're currently using resources almost twice as fast as the Earth's ability to renew them, right? So we are out of balance. That's not something we can do forever, right? Just like if you're overdrawing your bank account or racking up credit card debt, you might get away with that for a while, but you can't do it forever. It's not sustainable. Right, last year in 2020, right, because of COVID, Earth Overshoot Day got moved later, right? The reason for that was, you know, we had all these lockdowns and people stopped traveling and going to work, etc. So our ecological footprint was reduced because of COVID, right? So here's kind of a history to show where we currently stand. Again, we're sitting at about 1.6 Earths, right? We're using the amount of resources equal to about 1.6 times the Earth's capacity to support them. So again, something that we cannot do forever. And as Alex mentioned in the video there, right, the buildup of carbon dioxide is one of the main drivers of our global footprint. That's a lot of what we're going to be talking about this evening. Right, we saw that our resource use was reduced because of COVID, but that's not something that's sustainable, right? We're trying to be sustainable here and have long-term reduction in resource use that's by design rather than disaster, right? COVID was to some extent a disaster, right? That's not what we're trying to do here. We're trying to reduce our resource use in a controlled fashion to make sure that we can all live within the means of the Earth. Okay, so we're going to talk about a couple topics here that underpin our discussion of sustainability. We'll talk about population growth, economic development. We're going to look at how water and energy and food are interrelated with each other. And then we'll spend a lot of time talking about global climate change. So again, this is context. These are the circumstances in which we as construction professionals will operate in the coming years. We need to be aware of what's going on in the world around us, again, so we understand exactly why we have to minimize the human use of resources in our work. Right, here's a graph talking about world population growth. You know, it's kind of good news and bad news, right? The good news is that the line graph here is the rate of change or rate of growth, right? The rate of growth in population has diminished substantially, right? We're growing much slower than we have in the past, but still we could have, you know, 8 or 9 or 10 billion humans on the planet before the end of the century, right? That's a lot of people that Earth has to provide for. So again, good news is that we've slowed the rate of population growth, but still there are a lot of human beings on this Earth that are looking for resources. Again, a lot of lines on the graph here, but I try to highlight the important points here. You know, in the developed world, right, we're part of the developed world, the United States, Europe, Canada, Australia, New Zealand, right, the developed world, economically developed, growth rates are falling. Japan, growth rates are higher in the developing world. You know, in Asia and especially in Africa. And we have some countries that are experiencing a decline in population, right? If you see the line at 0 here, right, a number of countries, I think Japan is one that's currently in population decline. Western European countries are going to be the same way. China is going to be in that position again soon. Yes, James? You had a question? You raised your hand, James. Do you have a question? So in essence, where the people are in this world is changing, right? So populations in the developed world are slowing and perhaps even shrinking. And the developing world, especially Africa, is where populations are growing. Right? Africa's share of the world's population is growing. Right here is Africa. The impact of humanity on Earth is really a combination of the numbers of people and the affluence or the economic development of that population. Right? So it's not only the number of people, it's what level of material prosperity that those people are looking for. Right? So not only do we have a growing human population, but we have a lot of humans in the developing world that aspire to the same level of material prosperity that we in the developed world have enjoyed. Right? We in the developed world have automobiles and cell phones and televisions and air conditioners and refrigerators, right? All the things that we take for granted in our life. And a lot of folks in the human beings just like us, no different than we are, in Africa and India and South Asia, right? They aspire to have those same things that we in the developing world, we in the developed world have had, and it's really not fair for us to say, oh no, you can't have that. Yeah, we have cell phones and color TVs, but you don't get to have that, right? That's not fair. So we have to figure out a way to balance all these things out. here's kind of an interesting graph that I found, right? The notion of well-being for all within the means of nature, right? We want to figure out a way that all human beings can have a good, rich life, all human beings on Earth, and still do it within the means of nature, right? Right now, even before all these countries in Africa and Pakistan and India, even before they all get air conditioners and refrigerators, right, we're already straining the Earth's capacity. So we, in essence, have a challenge here, right? We want to have high levels of human development, right, on the x-axis here, and we want to do it within the capabilities of the Earth's resources. This particular graph is showing how different countries of the world are doing in that regard, right? And this is where we ultimately need to find ourselves as human societies if we want to live sustainably, right? We want to provide a high level of development, and we want to do it in a way that we are not taxing the Earth's resources, right? That's a challenge. So what is human development? So this is the UN Human Development Index, right? Long and healthy life, knowledge, a decent standard of living, right? So life expectancy, education, GNI or GDP, right? So how much money is there in that society? So those are measures of well-being. This one's a little hard to read. Basically, the larger circles on the outside show the countries with the largest footprint, and I'm having a little trouble reading it here. So, but here's us in the United States, right? So in essence, the developed world, the Middle Eastern countries, you know, some of the oil sheikdoms are use a lot of resources. We in the United States do. A lot of the European countries do as well. Right. So again, we as humanity haven't quite figured out how to do this yet, right? No countries have yet been able to provide high social indicators with resource use within the Earth's capacity, right? We have countries in the developing world who have a low footprint, but they also have low social indicators, low human development index, right? And we have countries like the United States over here, where we have, generally speaking, a high development index, but we also have a high global footprint. So again, our challenge, you know, as construction professionals and as actually all human beings, is to figure out how to do both of these things at the same time, right? That's sustainability. That's what we have to figure out how to do. Okay, we'll talk a little bit about, right, one of the key resources that we need, and that being water. Right, most of the water that we consume is not used directly. It's used indirectly to produce the food we eat, the energy we consume, and the products we buy. Right, so we have Francis and I have a little water meter in our house, right? I'm an engineer, I'm a geek for numbers, so I periodically go down and look at our water meter and measure how much water we use on a daily basis, right? So we've been running somewhere around 76 gallons a day, right? So our direct domestic water use, right? That's the water for washing our dishes and drinking water and flushing the toilet, etc., watering the garden, right? That's a fairly small number relative to the actual amount of water that's embedded in all the products that we use and the energy we use, and especially in our diets, right? A lot of embedded water, right? If you look at the graph here, 634 gallons to make a hamburger, right? A lot of water is tied up in that hamburger. A lot of water tied up in a cup of coffee, in a gallon of gasoline, et cetera, et cetera. So the water that we require to live is not only how much we use directly in our houses, our domestic consumption, but it's also tied up in the products that we use. Right? Only, you know, we live on a blue planet, but really only a very small fraction of the water in our planet is available for us to use. Right? Most of that water that we see is tied up in the oceans. Right? Fresh water is a very small percentage of that, and a lot of that fresh water is tied up in glaciers and ice caps. Right? So really a percentage of water is actually available for us as human beings to use. So water is in fact a very scarce resource. And if we look at where water is used, the two largest water withdrawals is taking water out of the ground, right? The two largest water withdrawals in the United States are for irrigation. That means agriculture, growing food, and this being line down here, thermoelectric, right? That means electrical generation, the water that it takes to generate electricity. Those are the two largest sources of water uses, right? That's all the water that gets embedded in these sorts of things here, right? Watering the cow that gets slaughtered to make the hamburger, right? That's that water that's embedded in our hamburger. When we look at water use around the world, we see that some areas have scarcity due to a number of reasons, right? We have physical scarcity, or we have economic scarcity, right? In the case of the southwestern part of the United States, right, we see physical water scarcity, right? There's not enough rain that falls there relative to the demand of water, right? In other parts of the world, right, a lot of this is in sub-Saharan Africa or the Indian subcontinent, right? We have economic water scarcity, right? Peru as well, right? What does that mean? That means that those countries aren't developed enough. They don't have the level of economic development that allows them to provide water to their populations. Right? So we have places that are scarce in water because of physical factors or scarce in water because of development. But in both these cases, right, we have a shortage of water. So when we think about water, we have to think about the interrelationship between water, energy, and food. These three things are interrelated, right? We need water to produce food. We don't always see irrigation in this part of the country, but if you certainly if you drive west, you'll start to see these irrigation rigs, right? My son and my grandchildren live in Denver, so now with COVID, we've been driving to Denver rather than flying, right? So, you know, you drive across Illinois and Iowa, and you don't see much in the way of irrigation. As soon as you cross the Missouri River into Nebraska, then all of a sudden you see farmers growing corn, and they have these big irrigation rigs, right? So they're pumping water, they're pumping groundwater, and they're using that to water their crops. Other parts of the country, they'll be, you know, diverting water from a reservoir, and again, using that water for irrigation. Right? We need energy to produce food as well, right? So again, you saw the footprint, the water footprint of that hamburger, right? That water footprint comes from the water that it takes to grow that food, as well as the energy that's also needed to produce food, right? It takes energy to drive that tractor around. It takes energy to find my pointer here, right? Takes energy to pump the water out of the ground to spray in the irrigation rig, right? takes energy to produce food. We just talked about water is also needed to produce energy, right? Here's a thermoelectric electricity generating station, right? We need water to condense the steam in that turbine to complete the cycle, right? So we're using a lot of water to generate electricity. We're also using a lot of energy to pump water around. Right? It's if you know where Navy Pier is, right? Just north of Navy Pier is the Jardine water filtration plant, right? That's where all the water that we have in this area comes from. You know, that water filtration plant has big pumps that pump all the lake water through the filtration process and pump it around to all our houses, so when we turn the tap on, water comes out. And the situation of moving water around is much larger in other parts of the country, right? These pipes here are outside of Los Angeles, right? Los Angeles, essentially the water has to get pumped uphill from elsewhere from Northern California to get to the city of Los Angeles, right? So changes in one area, either positive or negative, will impact the others. So obviously we want to find ways of reducing energy. If we reduce energy, it saves water. If we save water, it reduces energy. And also if we potentially change our diets, that saves those resources as well. Right, here's some pictures of water supplies that are stressed by drought. This is Hoover Dam or Lake Mead. And I think it's probably even worse now than when I put these pictures in the slide deck a couple of years ago, right? This is just Hoover Dam and Lake Mead are just outside of Las Vegas, right? Because of reductions in rainfall in the Colorado River Basin, water levels in that lake are falling. As a matter of fact, I think I gave you a discussion board article to read and to post, right, about some of the issues, the stresses, the challenges that will be faced in that part of the country as the amount of water is diminished relative to humans' demand on it. We have the same situation in California. Right? California has been experiencing drought for many, many years. I ran across this a couple years ago, right? Places where, major cities where they were projected to run out of water. Right? We haven't gotten to that. We haven't gotten to day zero yet in Los Angeles or Las Vegas or Phoenix, but certainly it's foreseeable that we could face those challenges if we don't somehow get our resource use and the availability of resources back in balance. Right, so this was day zero in Cape Town. Cape Town is a major city in South Africa. Right, they were afraid that the water was going to run out. Right, can you imagine that? If the water suddenly ran out, it seems hard to believe here in the Midwest. We sit right next to a big lake, right? But turn your tap on and have nothing come out, right? That's day zero. Let me put on another video here. Hold on, and I'll remember to.
Whatever there is to find, the sheriff's going to find it. Last night, one of our own was found dead.
Sorry about that.
Please arrest my son.
போர் தண்ணியும் கிடையாது, குழா தண்ணி தான். இதை தான் நாங்கள் எல்லாத்துக்கும் யூஸ் பண்ணுறோம். எதிர்பார்க்கறதா இருக்குது. தண்ணியே கிடைக்க மாட்டேங்குது. 30 பேருக்கு அப்புறம் ஒருத்தர் பிடிக்க வேண்டியதா இருக்குது. அந்த 5 குடம் தண்ணியும் கிடைக்கல. ரொம்ப கஷ்டப்படுறோம்.
வாட்டர் மேனேஜ்மெண்ட் பொறுத்தவரையில ஒரு முழுமையளவுக்கு வந்து கவர்மெண்ட்டை பொறுத்தவரை, அம்மாவுடைய அரசை பொறுத்தவரை, ஆட்சியை பொறுத்தவரை எவ்வளவு செய்ய முடியுமோ அவ்வளவு செய்யிருக்கு. இப்போ 499 கோடி ரூபாய் இப்போ வந்து அலாட்மெண்ட் பண்ணிட்டு, அதுவும் வந்து இந்த பணி வந்து நீர்நிலைகள் ஆழப்படுத்துறது, பலப்படுத்துதல், இதே போன்று குளம் குட்டைகளை தூர்வாறுதல், இது போன்ற எல்லா வகையான பணிகளை மேற்கொள்வதற்கு ஒரு 500 கோடி ரூபாய் கொடுத்துருக்கு.
Right, so there's an example of a city. Tamil Nadu is a state in southern India, right? So that's what it looks like when the water starts to run out. Right? A situation that others elsewhere in the world are facing, but doesn't seem that terribly far-fetched in some areas of this country. Right, so we're okay in Illinois, aren't we? Right, we live next to a great lake, a big lake. Well, actually, that's not quite true. You know, our water supply is also under stress in this part of the country. Certainly not as bad as it is. Let me turn the pointer on you, right? Certainly not as bad as it is in the southwestern part of the United States, but we have challenges here as well. Right? What's our challenge? Our challenge is that the amount of water that we can take out or divert from the Great Lake is limited by treaty, right? Because Chicago sits kind of astride the continental divide that separates the Great Lakes from the Mississippi watershed, right? We're in a situation where there's only so much water that we can take out of the Great Lakes. It's limited. So we have to manage our water here carefully as well. Right? What is that treaty? That treaty is the Great Lakes Compact. Right? It was signed by Great Lakes states and Canada, and it bans the diversion of Great Lakes water outside the basin. Right? Basin being the watershed. Well, that's good news and bad news, right? For us, it's a challenge because we in Chicagoland sit partially in and partially outside of the Great Lakes Basin, right? If you live in Oak Park, right, there's a little sign in Scobell Park in downtown Oak Park where the continental divide is between the Great Lakes and the Mississippi watershed. So we get to take Great Lakes water because, you know, our county, Cook County, is partially in the Great Lakes watershed, but as you get further outside of Cook County, then the amount of water that you can take out of the Great Lakes is limited. So that's a challenge, but the thing that's good about the Great Lakes Compact is it prevents states from elsewhere in the United States from thinking that they can build a big pipe and move Great Lakes water to Las Vegas or Los Angeles or Phoenix, right? We can't do that. Okay, any questions? So let's talk about global climate change. Sometimes you'll hear it referred to as the greenhouse effect. Right, here's my little greenhouse here in my corner of Southeast Oak Park. Right, how does a greenhouse work? The greenhouse keeps the plants inside it warm because the solar energy shines through the glass, and that energy warms up the plants and the soil inside the greenhouse, and that energy is re-radiated as long wave or infrared radiation, infrared heat, and then the glass prevents or traps that long wave radiation from leaving the greenhouse, right? That's how a greenhouse works. In this case, greenhouse effect is a desirable thing. Unfortunately, we as human beings, right, we've been burning fossil fuels, we've been producing carbon dioxide. The CO2 from our human activities is altering the composition of the Earth's atmosphere. So the same thing that we saw in the greenhouse, right, here's our little greenhouse in Southeast Oak Park, right? The same thing is happening on a planetary scale, right? Solar energy, incident solar radiation from the sun warms up the Earth's surface, warms up the land, warms up the sea, and that energy is re-radiated into space as infrared. But because of the fact that we are putting greenhouse gases, CO2 and other materials into the Earth's atmosphere, less of that energy can leave the Earth's atmosphere. It's what's causing the atmosphere to warm, right? That's the greenhouse effect, right? Climate Change 101, right? 101, and at least when I went to college, 101 was kind of the introductory class. So we're going to talk about Global Climate Change 101. This is something we could spend a lot of time talking about, but I'm going to try to move through it in this evening's lecture, right? So atmospheric carbon dioxide or CO2 levels have increased dramatically due to human activities. Due to the greenhouse effect that we just talked about, less of that radiation, less of that energy that comes from this is able to leave the Earth's atmosphere. So we are warming up the Earth's atmosphere. So what is more heat in the Earth's atmosphere means? Higher temperatures, means that we're melting the glaciers and the polar ice caps. We're melting sea ice and land ice. We have warmer oceans. We have rising sea levels, altered patterns of rainfall, more intense storms, right? All the things that if you watch the news on TV or you read the newspaper, all the things that you have been hearing about, right? This is the dramatic changes in the weather are things that are happening because of global climate change, right? This is a couple weeks ago in Western Germany, the border between Germany and Belgium. right? 200 people killed because of flash floods due to intense rainfall. Right here is some brave firefighters in California. This is fires burning currently now, 2021, the Calor fire. Right, this is a fire that threatens Lake Tahoe. If you're familiar with California, Northern California, we've got the other fires burning in California and in Oregon. Right, you add up all these numbers of acres that have been burned, and you start to lose track of, how much a million acres is. So just for comparison, the land area of Cook County, that's where we live, is 1 million acres. So when we talk about wildfires burning out west, where 2 or 3 or 4 million acres of forest is being burned up, right? Think of 3 or 4 or 5 Cook counties going up in flames, right? That's what's happening as a result of global climate change. Right, this is Hurricane Sally from last year. We just had Hurricane Ida on the news last week or the week before. Right, a slow-moving storm gathers strength over the warm waters of the Gulf of Mexico. Right, the hurricane picks up energy because of that warm ocean waters of the Gulf, and just as the science has predicted, all that energy and all that water ends up, all that energy ends up as wind. All the water that has been picked up ends up as rainfall, right? So this is Hurricane Sally from last year. I could have found the same pictures this year from Hurricane Ida, right? We had a Category 4 hurricane that hit just outside of New Orleans, right? Knocked out electricity for 700,000 or 800,000 people for the better part of a week or more. I think there were 25 or so killed in New Orleans, and then the tail end of that storm we saw about a week later, 42 or so people who perished in New Jersey and New York City and Connecticut because of flooding, right? That's climate change, more extreme weather events. Right, here's some slides from a couple of years ago, right? If you remember, here's Paradise, California. This town got destroyed due to wildfire. Right, here was my 2020 updates. Wildfires across the West Coast have consumed more than 3 million acres in California, right? At 3 million acres, that's three Cook counties going up in flames. Here's from a couple of years ago. This is Hurricane Harvey in Houston. $125 billion in property damage, over 50 inches of rainfall. Right, it took a number of years to fix all the damage caused by Hurricane Harvey. Again, this is a hurricane picking up energy across those warm waters of the Gulf of Mexico, and that ocean is warmed due to climate change. And I got to change slides here, so give me a second to do that. Sorry about that. The Blackboard here limits the size of the slides that I can post. So let me run through a couple more slides here. So I said that atmospheric CO2 levels have increased dramatically due to human activities. Well, how do we know that, right? How do we know that atmospheric carbon dioxide levels have increased? Well, we know that because we have been measuring that, right? We have the Keeling curve, right? This is a scientist who, and actually in the late 50s, started measuring carbon dioxide levels out in Mauna Loa in Hawaii. So over the course of 60 years, we have a data set that shows the amount of CO2, ppm is parts per million, right? The amount of CO2 in the atmosphere increasing regularly over the course of the last 60 years. If we go back before then, we see that CO2 levels have been increasing for many hundreds of years, right? That puts 1760 at the start of the Industrial Revolution, right? Industrial Revolution is when we figured out how to dig coal out of the ground and burn it in a steam engine and produce energy, right? That was really when the use of fossil fuels started to take off. And again, going further in time, right, looking at our increasing CO2 over the sweep of not, here's 10,000 years of human history, right? 10,000 years ago is when human beings figured out how to settle agriculture in Mesopotamia, right? In what is now Iran and Iraq. That was the beginning of agriculture, right? Human beings figured out how to grow stuff. Going back even further again, here's our CO2 levels now. So CO2 levels are higher than at any time in the last 800,000 years. We're conducting a science experiment that is unprecedented in human history, right? 50 or 70,000 years ago, modern humans walked out of Africa. So in all that time, as we as humans have been here, we've never had CO2 levels in the atmosphere as high as this. So let me stop here, which is 7 minutes before 8. So I'm going to take a break and get a drink of water, and we will pick up again a couple minutes after the hour.